Hey guys, Mr. Milton here. Today we're going to talk about systems, equations, word problems, or applications. At the end of this video, you should be able to solve and set up word problems by writing systems of equations. Okay, alright, so systems of equations can often be used to solve real life problems. Okay, so we don't just do this because it's fun to do. Just before we get into it, we want to make sure that we remember the three methods that we can use to solve a system of equations. Okay, so here are the three methods: graphing, substitution, and elimination. Okay, the times when you should use these. Graphing, if you're trying to solve an equation, sorry, I'm trying to center this. If you're trying to solve a system of equations, you shouldn't use graphing unless you're directed to. Okay, so really you shouldn't use it unless you're directed to. I guess the correct answer, the most correct answer would be graphing is used when you want to visually see the solution. So if you really want to see it happen on a graph, then yeah. Otherwise, for my money, if you're given a system of equations, use it to solve it either using substitution or elimination. Okay, use substitution when a variable is isolated. I'll just say when a variable is by itself. And you use elimination when both equations are in standard form. And it might be a little bit different because they might not use x and y, but standard form in the sense that both equations have the variables on the same side. Okay, so we're going to go through a few problems just so we can practice setting it up and solving. So let's go into the first example. A puzzle expert wrote a new Sudoku book. His initial cost were $864. Binding and packaging each book cost 80 cents, and the price of the book is $2. How many books must be sold to break even? Remember, breaking even means that he makes as much money as he spent. Okay, with these systems of equation problems, it's important to realize that they are giving you two equations. Okay, and so if you organize yourself to say, okay, there's two equations, then it makes it a little bit easier. In this case, they're giving us two equations, one about costs and one about gains. Okay. In both situations, they're talking about money, so I'm just going to use, I don't know, M. Okay, that's the money. That's how much it costs. Okay, so the money for costs is that it initially cost $864, and then it costs 80 cents more for every book that we make. So I'll say 0.8b. The price of the book is $2. That's how we make money. We make money by selling a book for $2 per book. Okay, so things that we don't know how much, when it's going to break even, we don't know how many books. Okay, two equations that gave us cost and gains. And so now we have this system. Okay, this system is set up for us really to solve by substitution. Notice that in both equations we have m by itself. So now to solve it, I'm just going to plug in 2b for m in this top equation. 2b will equal 864 plus 0.8b. I'll try to get b all the way by itself, so I'm going to subtract 0.8 from both sides. And that will give me 1.2b equals 864. Sorry, no decimal there. Okay, so I'll do 864 divided by 1.2. I mean, this expert needs to sell 720 books. Okay, so B is 720. Notice we did not have to find M for this problem. They don't care how much money he'd have to earn to make back his costs. but we could find that if we wanted to. Okay. All right, second problem. It's a coin problem. It says you have just enough coins to pay for a loaf of bread priced at $1.95. You have a total of 12 coins with only quarters and dimes. How many of each coin do you have? So here we go. Again, two equations. One about price. Okay, the price of the bread is $1.95. You're going to have to pay for it. And the other is about the number of coins. Okay. The coins part is probably the easier of the two to set up. You have two types of coins, quarters and dimes. Okay, when you put the number of quarters plus the number of dimes that you have together, you have 12 coins. Price. Price is $1.95. Now, with all these coin problems, the toughest part I find is decimals. A lot of people want to make a nickel worth 50 cents, make a dime worth $1, make a quarter. The decimals throw people off. So instead of thinking of this as decimals, I just think of it as pennies. I always think of it just as pennies. Okay, so instead of $1.95, I'm going to say 195. 195 cents. And this way I get to avoid all decimals, and it makes it a little bit easier for me. Okay, now we know that we're going to pay for this with quarters and dimes, but we have to think like every quarter is going to be worth something. So for each quarter I put into this, let's just say the cashier, I'm giving them 25 cents. So 25 cents per quarter plus 10 cents per dime. And so now I have my system set up, and it's just a little bit helpful now that I want you to label your equations. Okay, now this system is set up for elimination. Both variables are on the same side. Okay, and so I'm going to think of which one is easier to get to. I'll say dimes. Okay, it's easier to just multiply everything by 10. I'll rewrite my system here. 25Q plus 10D equals 195. I want to multiply this bottom equation by negative 10. So I have negative 10Q minus 10D equals negative 120. So now I can add all these equations together, and you'll see that I eliminated the D. So I have 15Q equals 75. I'll divide by 15 on both sides. And then when I do that, what is that? Is that 5? I think it's 5. Okay, divide both sides by 15 and you get 5. So there are 5 quarters. And now that I know there's 5 quarters, I can find out how many dimes there are. It's 5 plus Q, 5 plus D equals 12. So D would equal 7. And so I have 7 dimes and 5 quarters. Next problem, a grocer marks frozen yogurt toppings such that 8 pineapple toppings and 3 strawberry toppings cost $22, and 4 pineapple toppings and 7 strawberry toppings cost $22. Find the price of each type of topping. So here we go. We have yogurts. There's just 2 yogurts, so I can just say yogurt number 1, yogurt number 2. In yogurt number 1, we had 8 pineapple toppings, 8 pineapples, 8p, and 3 strawberry toppings. And we know that together that cost $22. Okay, make sure your S's, you can tell the difference between your S's and your 5's. In the second yogurt, I had 4 pineapple toppings and 7 strawberry toppings. And that also cost $22. Okay, and so there's our system. Pretty simple to set up in that case. Again, this system is set up for elimination because we have variables on the same side. Okay, which one's going to be easier to eliminate? Well, I could either multiply to get them both to be 21, or I can multiply to get them both to be 8. And so I'm going to multiply to get them 8. That seems easier to me. To do that, I'm going to multiply this bottom one by negative 2. So I have 8p plus 3s equals 22. And then I have negative 8p minus 14s equals negative 44. Combine like terms, That'll give me negative 11s. I say combine like terms by meaning add the two equations together. Equals negative 22. And then I'll divide by negative 11, so I'll get s equals 2. Okay, so the cost of a strawberry topping is $2. And now that I know that, I can probably figure out how much pineapple topping costs. So I'll do 8p plus 3, instead of s I'll say 2, equals 22. 8p plus 6 equals 22. 8p will equal 16. P will equal 2. So, pineapple toppings cost $2, and strawberry toppings cost $2. They're both $2. Alright, final problem. Ticket sales. Together, Max and Ralph sell 135 tickets for a benefit baseball game. Okay, so number of tickets sold. That's one of the equations. If Max sold 10 fewer than twice as many as Ralph, how many tickets did each boy sell? So Max tickets. Okay. So we have two things, and we're going to look for the totals here. That usually tells us what they're talking about. So they told us the total of tickets is 137, and they told us kind of a total for Max. Okay, so tickets for Max and Ralph, I'll just say M plus R. And they both sold tickets. They sold 137. And then they told us Max sold 10 fewer than twice as many as Ralph. So twice as many as Ralph minus 10. So here are two equations for our system. You can see that this system is set up for substitution. We have M by itself in one of the equations. And so, yeah, we're going to substitute to solve. And in our first equation, instead of writing M, we're going to write 2R minus 10. Okay, that substitutes for M, plus R equals 137. And now we can solve this because there's only one variable. 3R minus 10 equals 137. 3R equals 147. And divide by 3, and we'll get R equals 49. So Ralph sold 49 tickets. Okay, and that means we can find out how much Max sold. M plus 49 should equal 137. I think that's 88, but I'm not 100% sure. 137 minus 49, 88. And so Max sold 88 tickets. So Ralph 49 tickets. Max 88 tickets. Okay, one thing that I will say, please don't fall in love with X and Y. It's frustrating for students when they solve the problem and then they forget what they actually solved for and have to reread the problem and kind of redo the problem for themselves. Okay, notice how I use letters that I could easily say, oh, that stands for Max, R stands for Ralph, S stands for strawberries, D stands for dimes. Okay, as I look back at the problem now, I know what I'm talking about. So make sure you do that so that you are able to answer the questions and not just solve the systems. All right, see you.